Hello, my name is Tikhonova. One moment, I'll start sharing my screen. Let us begin. Hello, everyone. My name is Tikhonova. I'm the data scientist in the NLP team at Sberbank. And today, my colleague Alena Finogenova and we are presenting the new version, the new release of Russian SuperGLUE, the first natural language understanding benchmark for Russian language. So, let's dive in. Russian SuperGLUE is the result of the joint effort of Sber, Huawei, and High School of Economics. On its creation worked a large team of data scientists. You can see them on the slide. But before we start discussing SuperGLUE and its new release, I would like to start with the main problematics in the field. What does general understanding evaluation, or simply GLUE, stand for? Eventually, GLUE is a benchmark that stands for solving the natural language understanding task by modeling human intellectual ability with text. Text, as the richest and the most valuable source of traces of human thinking, can be considered enough to solve it at this stage. So, starting with that, the GLUE benchmark usually includes a set of tasks which combine strong content and simple format. To solve the task correctly, one should express the ability to recreate human thinking and intellectual skills like making conclusions, logical operations, common sense reasoning, and so on. While the format itself only requires to perform basic labeling of classification of two classes, for example. And of course, there are the training, development, and test sets and the public leaderboard. GLUE benchmarks were mainly motivated by the development of NLP and namely language models. Nowadays, language models went through the advanced stages of natural language modeling. Well-known language models such as BERT, GPT-3, Robert, and others show ability to extract complicated relationships from text. There are several general language evaluation benchmarks which exist nowadays. Among them are the prototypes of Russian SuperGLUE, GLUE and SuperGLUE. The problem is that most of the current benchmarks are English-focused, and Russian language is underrepresented. That is why we created Russian SuperGLUE in the first place. It was our initial motivation for creating SuperGLUE for the Russian language. This benchmark is an analog of the English project called SuperGLUE, and the project Russian SuperGLUE started in May, and last week we presented it on NLP conference. The link to our paper is here on the slide. The project consists of general language understanding evaluation tasks for the Russian language, which allow to measure language models' understanding abilities. All tasks are in one-to-one correspondence with the English SuperGLUE, which allows us to compare models between the languages. All tasks can be divided in 6 big groups: common sense, such as Ruse and Parus, NLI and entailment, law, and there is also tasks on machine reading. Little bit aside stands diagnostic data set called Lidirus, which is basically an NLE task, that is the entailment task, but in addition to that, it has a vast linguistic annotation, which allows to perform an interesting research about how well the model learns some linguistic and semantics features. Besides the task, we have a leaderboard with the best models. And we started in May, as I've already mentioned, and since then we've received many submissions. You can see the results on our leaderboard. In addition to that, we created a Python library called Giant Russian. It is an adaptation of the English library Giant, which provides an interface for fine-tuning transformer Hugging Face models, such as RuBERT, multilingual BERT, and others on Russian SuperGLUE tasks. It is quite simple and transparent, and on our GitHub you can find an example of its usage.
We're glad that many people responded and participated in our benchmark. Thanks to them, we have received valuable feedback. And despite the success of the version 1.0, we have found a number of shortcomings and problems that lead us to a new release. So what were the problems of version 1? First thing that caught the eye on the previous leaderboard was the Russe task. The results of models were extremely high, especially in comparison with the human performance. For example, mBARD achieved scores almost 99% of accuracy, while humans was just about 75%. That was very suspicious, but also predictable, while we converted the dataset from the original Russe and didn't made it from scratch ourselves, even the test set. So that was definitely the case of the data leakage that needed to be fixed. Second problem was machine reading datasets. We have 3 of them, and they're the most source and time-consuming for collection and verification datasets. And unfortunately, the size of them were much smaller than of the English analogs and had some flaws that I discussed more precisely further. We have also found some little bugs in JOND and on the website, so that also needed to be fixed. So in our release, version 101, we have fixed all these drawbacks and presented the updated version of the datasets, JOND support, and the website. The link for the repository and the web interface stays the same. We left the first version, but freeze it, and now we support only the second one. Please be careful with it. So what we have improved? First improvement was the datasets. All machine reading comprehension datasets were expanded and cleaned. We made 2 absolutely new test sets for Russe and Daniet Kwan datasets. We have updated JOND support for Russian as well. And another huge update is an interface of the website. Not just Sberbank, but our site also was redesigned. We improved the reliability of the model evaluation system on the website. We made it more strict and fixed some folder files names bugs. Also we refactor web interface and add some new features for account submissions. So now in profile, users can download their previous submissions and edit them. Users can also upload submissions not for all the tasks, it's not obligatory now. They can just upload one of the tasks and get scores just for it. Users also really received 2 emails when they decided to make the submission public. The one email is a confirmation that submit is on the verification step, and the second email notifies if the submit on the leaderboard or it was rejected by our admins. We have also edited the guide with steps to make the usage of our benchmark easier and clearer. Now I quickly remind you how the datasets we updated look like and discuss what exactly changed. The first one is a Russe dataset. It's a task for common sense. Given 2 sentences, each containing an anchor word, we should define whether the word is used in the same sense or not. For example, we have the first sentence «Бурые ковровые дорожки заглушали шаги», and the second sentence «Приятели решили выпить на дорожку в местном баре». So here, anchor word is дорожки, and Russian speakers can simply understand that the sentences are not the same here in this context. As I said before, we discovered that there is a possibility of the data leakage in this set, so we decided to recollect and redesign the test sets from scratch. First, we filter anchor words, cut the most outdated and rare ones, edited absolutely new anchor words that were not in the training validation sets. And next step, we have automatically gathered sentences from the open sources. We can use Lenta and some others. We took only new sources from this year, 2020, and then check the anchor words, word sentence in sentence manually. For the new test set, we scored the human benchmark. It was the same Yandex Toloco task, but on the new subset of the data. The human benchmark now its performance is 80% accuracy. The best model that we have also measured is almost 73%, and now we can see that these scores look much more reliable. The next dataset is a question answering dataset, Danet Qua. Here, given a passage, we should answer yes or no to question it. You can see an example with the moon, and here you can easily understand that the answer is yes. This dataset had a very small number of examples. We have edited more data following the original methodology, and also edited some extra data with yes/no questions that we collected while gathering other datasets. So in total, we have a training with 1,750 examples and validation test sets that have for about 800 examples. We have also manually checked validation test sets and changed the answer distribution in them, so that the number of yes and no questions became 50-50. In the previous version, the yes answers was the majority class, and models achieved 80% scores just because they always say yes, and now it's impossible. We measured human performance and models, and now human achieves on this task 91%, while model scores are not 80 anymore. On this task, 63% is the best for now. The next dataset is RUCOS. The task is to find the correct entity in the paragraph that best fits the placeholder in the query. You can see in the example, we have some text. There are several named entities that underlined. The query has a placeholder, and we should find the correct entity to fill it. In this task, we expand the dataset, all three sets. Train not so much, but the size of the test set validation set were doubled from about 4,000 examples to 7,500 examples. The methodology was absolutely the same, but we also checked the balance of classes in them and manually verified the answers in test set and validation set. And the last data set we changed was new Series C task. It's reading comprehension dataset. The task is to answer the question based on the text paragraph. Answers are independent from each other, but questions are multi-hop. Multi-hop means that to answer the question, model needs to analyze multiple sentences from the paragraph. In the new version, we expanded the train set and cleaned typos and grammar mistakes in the whole dataset.
Let us now move to the coding part of Russian SuperGLUE and discuss how you could train your models on Russian SuperGLUE and make a submission on our website. In addition to the SuperGLUE site, we have a GitHub project with all the datasets, the TF-IDF baseline, and a Python library I've already mentioned called Giant Russian, aimed for fine-tuning transformer models on SuperGLUE tasks. Initially, it supported only main transformers, and now we've added the support of GPT-3 and GPT-2. So, in general, what's new in Giant Russian version 1.1? Great news, we've added GPT-3. So if you want to train RU GPT-3 large, for example, on Russian SuperGLUE, do not hesitate, you're welcome. Then we found that in the older version, there was a minor bug with the Ledirus preprocessing and prediction, and we fixed it. So please use the new version, it works better. And we also fixed some minor bugs in logs and so on and so forth. You can find the example of the library usage on our GitHub. We try to make it pretty transparent and clear. Let us now quickly go through the Russian SuperGLUE tutorial. and discuss how to make a submission. First of all, you need to download the datasets, of course. For this, visit the tasks page. There you can download separate tasks or press download all tasks to download all datasets at once in one zip. All datasets are in JSON-L format. And on a site, you can find a careful description of the structure of each dataset and each JSON-L. Then, in order to make a submission, you need to make prediction for the test sets for each task and name them correctly. Here on the slide, in the right part, you can see the names. You should name the answers with the name of the task, JSON-L. This is important because without it, we won't be able to check your submission. And Lidero dataset stands a little bit aside from the others, and it is used as an additional test for Terra. So you need to use Terra task for predicting Lideros. There is a FAQ on our website, so there it is explained in more detail, and we try to answer all possible questions there. In order to make a submission, you should register on our site, and after the registration, open your profile and press plus to make a submission. You have to enter some details such as the submission name, URL, and attach a zip file with the predictions, of course. Congratulations! In a few moments, your result would appear on the leaderboard. You can see the results, and if you want to it to appear on the leaderboard, press the corresponding option. Your submission will appear there after we check it, and if we think that it is interesting and it is new. Russian SuperGLUE provides huge possibilities for studying language models. And today I'm going to talk about our experiments with the diagnostic dataset Lideros. It is an analytic task, which is the task of lexical entailment, and it is unique in two ways. First, it is the translation, the exact translation from English diagnostic dataset, and secondly, it has a vast linguistic annotation in 33 linguistic categories, which could be divided in 4 big groups: lexical semantics, such features like lexical entailment, factivity, quantifiers, etc. Logic, this is about negation, double negation, intervals, numbers, and so on. Predicate argument structure, and knowledge. And while during the translation, all the language and semantic features, they were preserved. Thus, diagnostic dataset allows us to make a comparison between English and Russian languages. For example, we study SberDevices performance on English and Russian diagnostic datasets with respect to linguistic categories. We fine-tuned multilingual BERT on Terra and RTE, and predicted the quality, used it for the Lideros dataset. Here on the slide, you can see the results, and you can see that the overall performance is at the same level. For English, the matches correlation is about 0.2, and for Russian is 0.15, which is about the same. However, some categories are better solved in English, and some categories are better solved in Russian. For example, factivity, coordination, scope, and restrictivity is much better solved in Russian than in English. And for example, quantifiers and ellipses is much better solved in English. In order to examine this question further, And in order to study whether language models really learn linguistic features and how stable their performance is, we fine-tune multilingual BERT several times with different random seed initializations. And we measured the performance. And it could be seen that the results are quite unstable and correlation between random states is quite low. That showed that the prediction of language model are not stable and depend very much to the random initialization, which is not that good, of course. And we are now exploring the causes and how to increase the stability. And for example, we are now experimenting with data augmentation. This approach seems quite promising. This was our project Russian SuperGLUE and its new release. Thanks for your attention, and we hope to see you on our leaderboard. Do you have any questions?
Thank you, Masha. I don't see the questions in the chat. So actually, I have, once we have time, it's the first time today that we have time for the questions. Once we have time, could you please maybe you or maybe Alena give more details on the Russian SuperGLUE dataset? So you have described in details 3 datasets that have been updated in this new release, but what about the other datasets?
Alena, maybe you could answer this question.
Can you show the slide with all the datasets?
I'm in process of listing.
Yeah. Yeah, we have already discussed Russe and all machine reading datasets. We have also, Masha had said about diagnostic set. So we had also Terra and Russian Commitment Bank. That's textual entailment datasets. They looked like, it is some we have some sentence and hypothesis. And should define whether it's entailment or not entailment. So they're really very similar with each other, but the tricky ones. Parus is a dataset for common sense, and in Parus we have it's a COPA. It's an analog for English. Once it has.
Could you maybe give some examples if you have?
Wait a moment. Maybe
I think I could give an example. For example, Parus. In Parus we have, as Alena has already said, a premise. For example, гости вечеринки прятались за диваном. And we have a question, what was the cause of it? And so then we have two alternatives. Это была вечеринка-сюрприз, и это был день рождения. And the model has to reason that the correct choice is the first one. So, repeat. Гости вечеринки прятались за диваном, and the cause was это была вечеринка-сюрприз.
Yes, it's a parse task, and we have also a logic task, Russian VSD. It's schema Vinograda, Vinograd schema challenge. And this task looks like we have a text, for example, some sentence, for example, кубок не помещается в коричневый чемодан, потому что он слишком большой. And we should understand, is it чемодан or is it a кубок? Who is слишком большой? So it's a kind of very tricky logic task.
Yeah, it's as far as I remember, Vinograd schema challenge dataset is the direct translation. Maybe not like translation, more like transcreation, where we replace the unknown to Russian culture things. But still, what the sample you have been telling about, this is the classic sentence pair from the Terry Vinograd himself.
You're absolutely right. All examples were collected, manually translating and adapting original Vinograd dataset for Russian. And of course, there was a human assessment on Yandex.Toloka for that.
Okay, yeah. That is nice. Could you please give maybe a bit more details on the already presented models on your leaderboard?
Well, on our leaderboard, for the new release currently, we have Rubert models such as Rubert Plain and Rubert Conversational. And we also tested multilingual BERT. The performance of Rubert is the best. It shows high quality in Rousset dataset, Danet Koa, and Parus. We also tried, of course, RuGPT-3 models, RuGPT-3 medium, large, and small. However, here the tricky part is that we need to fine-tune hyperparameters, and this research, this is what we are now experimenting with. So, of course, if you try the basic default hyperparameters, the performance of GPT-3 large won't be the best it could show on fine-tuning the task. That is why maybe it performs on at the level which is quite the same as Rubert. But we hope that in the near future, we will be able to find the optimal hyperparameters which will yield to much better performance. And multilingual BERT performs reasonably well in all the tasks. However, it is worse than all the Rubert and RuGPTs. But multilingual BERT model is also very important because it allows us to experiment with English and Russian at the same time. And for example, to make linguistic comparison for the diagnostic data sets. And we can use it for different languages. That is good. That is why multilingual BERT model is very important as well. And of course, we have a TF-PDF baseline, which is very simple. And it's
okay. So thank you, Maria.